Alright guys, so in this video we're going to look at what I hope will be a really helpful example for you guys just to wrap your head around two variable or two group significance testing. So what's going on here is we have 10 bean seeds in this problem, and we're looking at how much these plants are going to grow over the course of 2 weeks. And the idea is that they're going to randomly assign 5 bean seeds to two different treatment groups here. One group is going to listen to heavy metal music, so really intense, loud music. And one group of bean seeds at night is going to have classical music playing instead. And we want to compare the growth between these two groups and see if the classical music makes a difference, because they do suspect in this problem that they think plants are going to grow better if they are exposed to the classical music. So we have to set up our hypotheses to begin this problem. And excuse my really awesome Microsoft Paint handwriting here. We're going to have an HO and an HA for our problem. Before I get there, though, I better set up my parameters, which are going to be means, because I'm looking at quantitative data right here. I want to see if the average growth rate is better with one treatment than the other. So my mu1, my first group right here, is going to be the true average growth rates or growth amounts with metal music playing. And then I would have mu2, which is the exact same thing, but with my classical music instead. So I could type that one out, but you guys get the idea. True average growth rate with classical music playing. Now in the problem, if you look at it, the null hypothesis is always going to be the statement of no difference, or in other words, the growth rate is the same. The average growth amount is the same no matter what music is playing. So we would have that the two means, when you subtract them, you get 0, or in other words, there's no difference between metal and classical music playing. In the problem, they say that they think classical music's going to do better. So that would mean that if we're looking at the difference right here, classical is going to be my second group. If this is bigger, if it helps it grow more, we would get a negative answer here. So our alternative is going to be that the mu1 minus mu2 is less than 0, or in other words, the average is higher for classical music. Now, anytime you conduct a significance test, you're looking for evidence for HA. And if you're looking for evidence for the alternative, you would want to find the mean for each group. Find the mean of this group right here, compare it to the mean of this group right here, and see if anything's going on. So my sample mean for the metal music, if you average those guys and you subtract the average for the classical guys, if you average the 5 numbers on the left, you will get 38.2. So that is the average of my 5 plants that listened to metal music. And then I would have to subtract out the 5 plants that are average that listen to classical music. The average of my second group is an 85.8. And if you subtract those two numbers, what you're going to get is negative 47.6. That is definitely evidence for the alternative, because I subtracted the means of my two groups. There was a difference of 47.6. In other words, classical, the average is 47.6 higher than metal. Two explanations for that. We always talk about what the explanations or evidence could be. Option 1 is this 47.6 occurred by chance. There is no difference between the groups, but just due to how I dealt those 10 plants to the two treatment groups, that difference occurred just based on the random assignments. And option 2 is that the classical music actually did make a difference, that the classical music actually did, the classical music group did grow more on average. So getting into how we test that, I'll save that for the next video. But in this video, the last thing I want to talk about, if we meet our conditions that we always check, would we want to do a paired test, or would we want to do a 2-sample test? The answer to this is definitely that we would want to do a 2-sample test. For this to be a paired data set, the numbers in each group that correspond to each other would have to actually go together. So that 22 for metal would have to link up to this 87 for classical. This 36 would have to match up with this 78. And in this problem, that's just not the case. Remember what you think about: if I shuffled up all the numbers in one or both of my groups, would it make a difference? And it wouldn't matter at all. If I mixed up these 5 numbers right here, they would still not, like you would get the same sample means, you would still get the same result right here. This is definitely a 2-sample problem.